In this lesson, you're going to learn how to factor a polynomial using what we call the grouping method. Let's take a look at our first example. Here we're going to factor x squared minus ax plus cx minus ac. Now if you look at the four terms, there is no greatest common factor of all four terms. The three letters we have here are x, a, and c. The first three terms have an x, but not the fourth. The second and fourth term have an a, but not the first and third. And the last two terms have a c, but not the first and second. So notice there is no variable that all four terms have in common, therefore there's no greatest common factor. However, when you have four terms, you can often use a method called the grouping method to factor this. When you do the grouping method, this is just the simple version of the grouping method. What you do is you group the first two terms together and then the last two terms together. You're actually going to factor out the greatest common factor of just the two terms that I put together in parentheses. So if you look at the first group, x squared minus ax, what is their greatest common factor? Hopefully you can tell they have an x in common. So what you're going to do is pull out that x, because it's the greatest common factor, and then simplify inside the parentheses so you have your remaining binomial. So for the first term, x squared over x to the first, if you subtract the exponents, you'll have an x left. For the second term, the x's will cancel, and you'll be left with an a. We're now going to do the same thing with the second set of parentheses. So cx minus ac, both terms have a c in common. So the c will be the greatest common factor. So in the first term, the c's will cancel out, leaving you with an x. In the second term, the c's will cancel, leaving you with an a. Now, once you factor out the greatest common factor of each set of parentheses, we're then going to bring these back together. And the way that we do that is this. You should notice that the remaining binomial in parentheses match. So what we're going to do is drop down just one of the two binomials that match. So the x minus a will be one of the factors. Now the greatest common factors, the x and the c, we're going to combine together and make a binomial out of that. Since the c is positive, we're going to use a plus sign between the x and the c. So to get your second binomial, you use the greatest common factors, which is the x and the c, and then you put the sign of the c in front, which would be a plus. And these would actually be the factors of our original polynomial. And if you were to FOIL that out, you would get the original polynomial. So one way again that you can see if grouping would work is you always look to see if there are four terms. That would be the clue that you would want to try the grouping method. But first, before you ever try the grouping method, always look to see if the four terms do have a factor in common. And if they don't, then try the grouping method. Let's look at an additional example. So in this example, if we look at all four terms, 2a squared plus ab plus 2a plus b, they don't have any factors in common. The first three have an a, but not the last. The first and the third have a 2, but not the second and fourth term. And the second and fourth term have a b, but not the first and the third. So there is no variable or number that all four terms have in common. Once you've ruled this out, you can then move to the grouping method. So let's go ahead and group our first two terms and our last two terms together. What do you see that 2a squared and ab have in common? They both have an a. So we'll pull that a to the outside, and then we'll simplify each term to see what's left in parentheses. For 2a squared over a, we'll drop down the 2 and subtract the exponents of the a, leaving us with 2a. For the second term, ab divided by a, the a's will cancel, leaving you with a b. In the next set of parentheses, 2ab, notice that there is no common factor. So the question is, what do you do? Let's go ahead and just drop that down. Now you can see that the binomials match, so we know that will be part of our answer. The question is, what will be the other binomial? Well, like anything, a variable or a radical, anything that doesn't have a number in front, it's like there's an invisible one. So in this case, we'll just put an invisible one or positive one. So we will actually combine the a and the positive one to make our second binomial. And again, if you were to FOIL these two binomials, you would come right back to the original polynomial that we started with. Now don't stop here because there's some more examples with a little bit of a different twist on them. Okay, in this particular problem, there's two new things. First thing, when we look at all four terms and you're looking to find a greatest common factor first before you jump to the grouping method, there actually is a common factor of all four terms. Can you see it? Hopefully you can see that you could factor out a 4 of every term. You cannot factor out a t because the fourth term, the 24, does not have a t. But they do all have a 4 in common. So let's go ahead and take out that 4. That would leave us with t cubed minus 3t squared minus 2t, and we're just dividing the numbers, plus 6. Now that we've gotten the greatest common factor out, now we can group the terms together like this. And now we'll factor out the greatest common factor of our remaining terms. So in the first set of parentheses, t squared is in common for both of the terms. So we're going to bring that to the outside. Now when you bring that to the outside, be careful how you write it. You've got to drop down that 4, and you'll probably want to use brackets to separate what you're going to get when you factor by grouping the remaining 4 terms separate from the 4. So you'll have the t squared, and then when you subtract the exponents of the t's, you'll have t for the first term minus, and then these cancel, 3 for the second. If we then move over to the second set of parentheses, you can factor out a negative 2 from those. So if you bring out a negative 2, you'll have t minus 3 for the second. Now, the biggest problem with this is knowing if you factor out a negative 2 or a positive 2. If you would have factored out a positive 2, let me show you what that would have looked like. So if we would have factored out a positive 2 instead of a negative 2, we would have had 2 on the outside, and then a negative t plus 3 on the inside. But in this case, can you see that the binomials do not match? And it's very important that they do. So if you notice ahead of time that these two signs are different, that's your clue that for one of the two, usually the second set of parentheses, you'll need to factor out a negative number so that it will switch the signs, which will then give you matching binomials. So let me go ahead and fix that back to where it was. So if we factor out a negative 2 instead of a positive 2, you'll see that the binomials are now matching. So now to finish this, again, we'll drop down the 4. The t minus 3 will go in one parenthesis. Then our greatest common factors, the t squared, and then the negative 2, will be combined together to make our second binomial. And again, if you were to FOIL your binomials and then multiply every term by 4, you would get back to our original polynomial. And that completes the lesson on factoring by grouping.